Hello friends, subscribers and new viewers of this channel. In this tutorial we explain how to install Ubuntu Linux on the Raspberry Pi. I must say that I'm really positively surprised because I was able to run full Ubuntu desktop on my Raspberry Pi that has only 4 GB of RAM. This discovery is really important for me since I'm interested in robot operating system and I plan to use Raspberry Pi 4 or 5 to create a mobile robot. But before I start with explanations, I need to mention the following. Most online tutorials on Raspberry Pi suggest to use a micro SD card to install Linux Ubuntu. However, I discovered that the performance of the overall system is much better if we use a solid-state drive, such as this one over here. This is a Buffalo 1 terabyte solid-state drive, or if you use a solid-state drive that looks like this, for example, a SanDisk solid-state drive. Both of these solid-state drives are actually external solid-state drives. My discovery is that the read and write speed of the solid-state drive compared to the micro SD card is at least 10 times faster. And this is really important if you plan to use your Raspberry Pi for read and write extensive tasks. And this is especially the case for the robot operating system. Consequently, I suggest everyone who want to use Raspberry Pi for robotics applications is to use solid-state drive. If you don't plan to use your Raspberry Pi for tasks requiring fast read and write, then micro SD card will also work. I suggest that you buy a micro SD card that has the capacity of at least 32 GB. In this tutorial, I will be using this solid-state drive to install Linux Ubuntu. This solid-state drive is produced by Buffalo and has the capacity of 1 terabyte or 1000 gigabyte. But before we start with explanations, here is the summary and important notes. The first step is to create a Linux Ubuntu installer by creating a bootable solid-state drive or a micro SD card. In this tutorial, we will be using a solid-state drive. If you do not need to perform fast read or write disk operations, then you can also use a micro SD card. Then, in this tutorial, we will explain how to install Ubuntu 24.04. However, everything explained in this tutorial applies to any other supported Ubuntu distribution. Finally, we will use a Raspberry Pi 4 with 4 GB RAM. However, you can also use any other version of Raspberry Pi 4 which has at least 4 GB RAM or Raspberry Pi 5. Then, after the first step is completed, we will boot the Raspberry Pi by using the created bootable medium from step 1 and we will install the Ubuntu Linux desktop and configure the system. Then, we will optimize the performance in order to improve the speed. And this step is optional. If your Raspberry Pi and Linux Ubuntu work okay, you don't need to do that. However, I'm going to still show you how to overclock the system. That is, we will overclock both the Raspberry Pi CPU and GPU to increase the performance. Furthermore, we will increase the size of the swap file in order to improve the stability and performance. And here is a very important disclaimer. We don't take any responsibility if after overclocking the system becomes unstable or crashes. In our case, the system remains stable after overclocking. We have a heatsink and a cooling fan attached to our Raspberry Pi that keeps the temperature constant. However, it might happen that if Raspberry Pi is not properly cooled, the overclocking process might overheat the processor and create irreparable damage. We don't take any responsibility for this or if your system crashes after overclocking. The crash of the system can easily be repaired by reverting the settings. However, if your CPU or GPU overheats, the damage can be irreparable. Consequently, always be careful when you overclock and do not try to push the performance to its limit. Okay, let's start with the first step. Go to the official Raspberry Pi webpage and go to the software section, or immediately go to this webpage. And this webpage will lead you to Raspberry Pi operating system installation instruction. In this video tutorial, we are not going to install Raspberry Pi operating system. Instead, we will just need to install Raspberry Pi imager such that we can create a bootable disk. Consequently, since I'm on Windows, I will click on Download for Windows. And the download process will start. I will save it over here in my Downloads folder. And after that, I will open the file. And I will install it. And this will take several seconds to install it. And click on Finish. Next, let's run the Raspberry Pi imager. To do that, click here and search Raspberry Pi and click here. And here it is. Over here we need to make the proper selection. First of all, let's choose the device. Click here and find your Raspberry Pi. In my case is Raspberry Pi 4, however you can select Raspberry Pi 5 if you have it. Click here, then let's choose the operating system. Now, over here you have to be very careful. We are not going to use the Raspberry Pi OS or the operating system. We need to select this option, Other General Purpose Operating Systems, and click here on Ubuntu. And then over here I will select Ubuntu Desktop 24.04. Of course, you also have some other versions of Ubuntu, such as Ubuntu 22.04 and even Ubuntu 20.04, which is still supported. However, let's go at the top and select this Ubuntu version, and let's choose our storage. Click here, and in my case, I will select my SSD. Of course, you need to plug in your SSD, otherwise you're not going to see your storage or your SD card if you're using the SD card. So click here and click on Next. And then you will get this message. Make sure that you don't have any important data on your SSD or micro SD card, since it's going to be automatically erased. So click on Yes, and now the bootable disk will be prepared. And this might take even 5 to 10 minutes, so be patient. Then after some time you will see this message. This means that our bootable disk is created and we can proceed. Next you can click on Continue. You can close the Raspberry Pi imager, and then you can eject your solid state drive or a micro SD card. Now unplug it and let's proceed to the next step. In the next step, we are going to insert our bootable disk or a micro SD card to our Raspberry Pi, and we will boot it. Next, let's learn how to set up Raspberry Pi, that is, how to connect the keyboard, monitor, our disk, and other peripherals. Okay, you can either use this type of Raspberry Pi without a fan. However, I strongly suggest you to install a fan and a heat sink. They're not expensive and you can easily buy them. In this video tutorial, I will use actually this kit over here. I'm not promoting this company, I just found this old kit. And as you can see, I have two heat sinks over here, and there is a fan over here. You can just buy a fan and a heat sink and put it on top and enclose it in something, or even 3D print something. Okay, next, we need to connect the keyboard and we need to connect our mouse. So what I like to do, I like to buy this type of expander such that I can have more USB ports. However, you don't need to do that. And you will attach this expander to one of these USB 2.0 ports. Don't connect them to USB 3.0 since they're much faster and they should be used for your not micro SD card, your SSD card. And make sure you connect them over here. Good. Then let's connect our keyboard and our mouse. So here's my keyboard. Here's my mouse. Then you need to connect your disk or your micro SD card. Micro SD card usually goes on the other side over here. However, you should attach your SSD to this USB 3.0, that is to these ports over here. So let's do that. Okay, attached. Next, I need to attach the power supply. In my case, I got this power supply, and let's see the specs. You should see the current rating. The current rating is 3 amps, and this is very important, and you can see other things. However, if you purchase Raspberry Pi, you probably got the power supply. So here's the power supply connector, and you need to find the appropriate port. So if you look here, there is a micro, HDMI, and here is the power supply. And here it is. Okay, the next step is to connect our micro HDMI cable. Here it is. This cable is used to connect the monitor. Now here is a very important suggestion. Over here you have two ports. You have this port and this port over here. This port over here is closest to the power supply, and don't connect it to this one, connect to this one. Otherwise you are not going to be able to use your speakers. Namely, this port over here is used to attach your headphones or to attach an external speaker. Consequently, I will attach my HDMI over here, and that's it. After you turn on the power supply, that is, after you turn on your Raspberry Pi, you need to wait for a while, maybe several minutes, and after several minutes you will see this screen. This means that the installation process has started. Over here, choose your language, then click on Continue, and choose Keyboard Layout. And over here, you can connect to your network. Next, enter the password for your network, and then click on Connect. And click on Connect. And now wait until your network is being recognized, and you can simply continue. Now, enter your time zone. I'm just going to use this default time zone. Enter your name and choose a password for your login. Of course, you cannot see my password, and I'm not going to require my password to log in, so I will click here on Login automatically. However, you should consider this option, require my password to log in. Click on Continue. And this should install the system. Depending on how fast is your SSD or micro SD card, it might take maybe even 10 minutes to install everything. In my case, it's going to be super quick, since the write access to my SSD card is super fast. And then approximately 5 or 10 minutes, you will see the screen. Now the computer will be automatically restarted, and you have to wait. Some additional things will be installed and some dependencies will be resolved. Consequently, be patient, since the installation process is still not completed. And the computer will be automatically restarted, and you will be required to log in. In my case, I didn't have to log in, since I set the option that Ubuntu will automatically log in. And here it is. Here is our Ubuntu Linux. It looks perfect. So let's click here Next. And I will just skip this option for now. Click on Next. And then I'll click here and click on Next and Finish. And that's it. Next, I will log in inside of my Ubuntu. In the sequel, I will explain how to overclock your CPU and GPU. Here is the motivation. If you're using Raspberry Pi 4, you might consider to increase the speed of your CPU and GPU by overclocking. This will increase the speed of execution of some programs. However, as explained at the beginning of this tutorial, inappropriate overclocking can create instability or, in the extreme case, burn your CPU or GPU. Consequently, it is important to have proper cooling system installed. On the other hand, if you're using Raspberry Pi 5, you might not even need to overclock since Raspberry Pi 5 is faster than Raspberry Pi 4. Here are some important notes. The standard CPU frequency of Raspberry Pi 4 is 1500 MHz. Online, it is reported that Raspberry Pi 4 remains stable up to 1950 MHz and instabilities have been reported above this frequency. On the other hand, the standard GPU frequency is 500 MHz. We have noticed that it is okay to push this to 750 MHz. Before you overclock, you have to make sure that you have a fan attached to the Raspberry Pi 4 and that the heat sinks are attached to the CPU and GPU. Also, you have to make sure that you have a proper power supply that is rated for at least 3.5 amps. Okay, so how to overclock Raspberry Pi 4? First of all, open a terminal by clicking here and searching for terminal. And click on terminal to open it up. Now, the first time you open terminal, it might be a little bit slow to open it up. The first thing you need to do is to run these two commands, sudo apt update and sudo apt upgrade. This is very important. And if you're running these commands for the first time, it's going to take a while to execute them, so be patient. Next, you need to execute this command. That is, you need to edit this configuration file. So let's do that. And here it is. Now, over here, at the end of this file, you need to add these three lines. First of all, we need to increase the voltage. The voltage should be set to 6. This is actually the voltage level, not exactly the volts. Then we need to specify the overclock frequency for our CPU. The stable value that people have reported in the literature is 1950 for this value. However, I have noticed that in my case, everything works fine if I put this frequency to 2000 Hz. However, you should first start with a lower value, for example with 1700, and then iteratively increase it. That is, set this value, restart the computer, see if everything is working, then increase a little bit more until instabilities occur. And over here, I'm setting the GPU frequency to 750. First time you open this file, you will not see anything over here, and consequently, you need to enter these three lines. Once you do that, you need to save this file. To save this file, press Ctrl S, or you can press Ctrl O and then press enter, and let's exit by pressing Ctrl X. And that's it. Simple as that. And this will overclock your system. Now, there is a way to verify that these commands will take the effect, and I will explain this later on. However, we will also need to restart the computer before these changes can take the effect. Consequently, restart the computer. You can do it easily even by using command line by typing sudo reboot, and this will restart the system. Or you can click here and then go over and restart the system. After restarting the system, let's learn how to monitor the CPU frequency. To do that, again, open a terminal. And in the terminal window, we need to type this command. Let me expand this window such that you can see what I'm typing, and here it is. Now if I execute this window, or actually execute this command, you can see the frequency over here, and this means that we are currently running with 2000 megahertz. Of course, for example, if you're doing something, you will see that the memory, or actually the CPU frequency, is increased or decreased. However, we are really at the maximum right now. This is because I'm recording this video. You can actually see what's happening behind the scenes by opening a new terminal and by typing top. And over here you can see the memory consumption, the CPU consumption, etc. I'm recording this video by using the program called Kazam, and you can see that the Kazam is using most of my CPU bandwidth. Next, we explain how to boost the performance and improve the stability of Raspberry Pi by increasing the swap memory and the swap memory file size. Loosely speaking, swap memory will virtually increase RAM size. On the other hand, it will occupy some extra space on your SD card or on your SSD. It will be used in addition to the regular RAM memory, and especially when the RAM memory is totally consumed. That is, the applications can store their data and processes in the swap memory. By increasing the swap memory and the file size, we can improve the stability and prevent some applications from crashing. Next, we explain how to increase the swap memory file size. First of all, let's open a terminal. Over here, be patient. Since first time you open a terminal, it will take some time. And what you're seeing currently is a slower version of what actually is happening behind the scenes. This is mainly because I'm currently recording this screen and my voice, and this significantly slows down the computer. First of all, let's type this: sudo swap on show and enter your password. And you can see that the current swap file is 10 gigabyte. Over here, I already increased the file size. When you first time run this command, you will see that the default value of swap file is only 1 gigabyte. And you want to increase that. Another thing that you can write is this command, free h. And this will list all the available partitions, and you can see how much memory is being used and how much memory is being used in your swap file. This is another very useful command. Before you make any change, that is, before you change the file size, you can actually run this command, and this command will turn off the swap file and the swap memory. That is, it will turn it off, to be more precise. We change the swap file size by executing this command. Over here you can specify the file size. Here I'm specifying 10 gigabyte. However, you can use any other value. My suggestion is, if you have enough space on your SSD, increase the swap file size. Next, we need to set the permissions such that only the user can read and write, and we can do it like this. Next, we need to create the swap space, that is, we need to implement our changes, and we do it like this. And you can see, wiping old signature and creating a new signature. Now we need to enable back our swap file, and we need to turn on the swap memory, and finally we can check the status to make sure that we have properly implemented everything, and we can do it like this. And you can see the swap file size, it's 10 GB. Okay, that's all for today, and thanks for watching. But before I even conclude, I also need to show you one additional thing which I forgot. Namely, if you open a new terminal and if you type top, you will actually see the swap file size. Okay, that's all for today, and see you in the next video tutorial.